Design of shaft. So till now we have seen how to design a shaft based on strength basis and based on the theories of failure also. We have seen the design of shaft based on the ASME code also. Now for the spline shaft. Spline shaft is a type of a shaft only. Now what is spline? We know that it is nothing but a key integral with the shaft. To connect a shaft with a hub of a pulley or gear, what happens? We need to insert a key so that they should not have any relative motion between them. And sometimes we use a press fit connections. So maximum time keys are used, but this keyhole reduces the strength of the shaft. And that's why this spline shaft is being developed. Now, what is this spline shaft? I will show you. It is used, as I showed you. Splines are the cut on the shaft by milling and on the hub by broaching. A spline connection with straight spline, and there are different types of spline we are going to see. Uh, this is a spline. Okay, you can see this is a shaft, and a gear type of structure is being made on it. And it's the difference between the gear and the spline shaft is what? Its length. The spline shaft length is more, and the gear length is less. So D is the major diameter, small d the shaft diameter, and this is the pressure which is acting on it, and this is the hub where it is going to shift. This spline shaft is used in so many applications, in lathe machines, in gear shifting. You are going to see the spline shaft and all these things. Okay, small d is the minor diameter, as I told you, the shaft diameter also. Length of hub L, or you can say, and N is the number of splines. Now MT is the torque transmission, PM is the pressure, it is the permissible pressure on the spline, A is the total area of spline, and RM is the mean radius of the spline. Therefore, the area is given by this term here, 1 by 2 capital D minus small d ln, and mean radius is given by capital D plus small d by 4. So the torque can be written as torque is equal to what? Force into perpendicular distance, and like this. So 1 by 8 pm ln capital D square minus small d square. Permissible pressure on the spline is limited to 6.5 Newton per mm square. This pressure is fixed here. And we have some more different types of spline. Let's see. One is the involute spline. Okay. This is how a straight threaded spline, which we have already seen in the previous slide. This is general spline shaft which we used. And then involute spline, it is having a structure like a gear. Okay, it's having an involute profile. So this involute profile help us to give a lesser friction. So they are stub teeth with pressure angle of 30°. These splines are specified by modules also, and involute splines are more popular than straight spline due to greater strength related to their size. This will create a more stress concentration here, and this created a less stress concentration. That's why. So involute splines are self-centering and tend to adjust to any even distribution of loads also. Now the next, the serration. Let's see the serration also. This is how the serration. It's having a notch types of structure. Straight-sided serration are used in application where it is important to keep the overall size of the assembly as small as possible. Even in toys also you will find this serration types of keys or the straight types of, because in toys you will find many spline shafts are used there. So they are used at interference joints. Serration joints are also used to obtain small angular relative adjustment between the joints member. So these are the different types of spline which we have seen. So this is how the spline shaft works. Okay, thank you very much.